Hello and good evening to all of you. Am I audible? Okay, so what are we going to do today is to understand some of the basic concepts of light and sound. So these concepts of light and sound, they are essential for you to understand even when we are doing science and technology in civil services. So when you are preparing specifically science and technology in civil services, you will see the concept of light and sound is used at multiple places. If you look, so you will see application of concept of light even in space science and technology, application of light and sound in defense science, in defense technology. So missiles, how do they work upon, or the missile defense system, how do they work upon, how does you detect something, so radars or sonars, so they are using the concept of sound. So radars are using concept of radio waves, a similar type of wave. So light is also electromagnetic wave, radio wave is also electromagnetic wave. So we'll try to develop a understanding so that the topics in light and sound you are able to understand and you are able to see its application in the topics of science and technology for civil services also. So that is our objective. So light and sound, when you say light and sound, they both are referred as waves. What do you understand by waves? When we say both light and sound are waves, what do you understand by waves? So waves are of different types. When you say light and sound are waves, hi Ram. Okay, so when we are saying both light and sound are waves, so what do you understand by waves? There are two types of waves. What are two types of waves that you have studied in school or that you are aware of? There are two types of waves. One is known as mechanical wave and the other is known as non-mechanical wave. So one is mechanical wave and the other is non-mechanical wave. What do you mean by this? What do you mean by a wave is mechanical and a wave is non-mechanical? Let us just first try to understand what is wave. आपने कहाँ देखा है wave? Can you give a daily life example of waves? Can you give a daily life example of waves? So let us say you are sitting by a pond, and if you throw a stone, you see waves are being formed on surface of water. Similarly, if you are a big fan of seasides, if you are sitting on the sea front, you are seeing waves that are coming towards you. Waves are nothing but periodic motion of something. Even your heart is beating. So it is beating, let us say 72 times in a minute. So that is also a form of a wave. It is also producing a periodic movement. So if you are a fan of gym, so in gym, have you seen those battle ropes? So you would have seen some people, they lift and pull down the ropes. So at one end they will stand and they will lift and lower the rope. So waves are being formed. So these are your waves. So what do you understand by mechanical waves and non-mechanical waves? See, in order to understand waves, you have to understand two aspects of waves. One is what is referred as wavelength and other is frequency. So if you understand wavelength and frequency, many of the concepts of light and sound you can easily understand. We will understand the basics of this wavelength and frequency, but let us look at what are mechanical waves and what are non-mechanical waves. Can anybody tell what are mechanical waves and what are non-mechanical? Let us first focus on mechanical waves. What are mechanical waves? कौन से waves को mechanical बोलेंगे? Yes, anybody? Which waves we can call as mechanical waves? Just give me an example also. That would also suggest that you have understood or you have some experience of waves. Yes, anybody? Okay, mechanical waves. So let me just point it out. So mechanical waves are the waves which require medium to propagate. If they are requiring medium to propagate, then these are called as mechanical waves. Like sound. Sound is what? Sound needs medium. Sound cannot propagate in vacuum. So sound is a mechanical wave. Non-mechanical wave are the waves which do not require medium. So the perfect example of a non-mechanical wave is your light. In fact, the electromagnetic waves, they all are non-mechanical. That is, they do not need a medium. So they do not need medium. So non-mechanical waves do not need medium. And waves are also categorized based on what is known as whether the wave is transverse or whether the wave is longitudinal. So non-mechanical waves are always transverse wave. Non-mechanical waves are always transverse wave. We'll just try to understand this. Mechanical waves can be both transverse and longitudinal. We'll try to understand these things through examples. So it can be transverse or it can be longitudinal. Transverse, how do we understand wave something as a transverse wave? So when you see that gym rope, in gym rope what is happening? The person is moving the rope or he is displacing the rope in up and down direction, but the wave is moving in 90 degrees to the movement of the hand. So the propagation of the wave is perpendicular to the displacement. So such type of waves are called as your transverse wave. Propagation of wave is in a different direction and movement of the particle is in different direction. Another example of transverse wave would be let us say if you are a fan of football. So have you heard about Mexican waves? Have you heard about Mexican waves? What are Mexican waves? So in a football stadium, people they sit and stand, and they do it in blocks. So one block of people will sit, most of the people would be sitting, one block of people would stand, and then the next block of people will stand. So what happens, that it appears that the whole stadium is moving, or there is a wave that is moving. So what is happening? The wave is moving, let us say, in a circular pattern, but are the people also moving in a circular manner? No, the people are just sitting and standing. So the direction of propagation of the wave is perpendicular to the direction of movement of particles. So that is why these are known as transverse waves. So light is also transverse wave. So light has this characteristic. So light, we say that it is a sinusoidal wave. So in this wave, what are these known as? These are known as your crest, and these lower part are known as your trough. And this distance between two successive crests is called as wavelength. This is called as wavelength. And what is the speed of wave? Speed of wave is given by lambda into frequency. speed of wave is given by lambda into frequency. So what is frequency here? Frequency means that how many times, let us say if we put a board here, then how many times the wave is going to hit per unit in a particular fixed time. So let us say in 1 minute how many waves will come and hit it. So that is what is known as frequency. So frequency is referred as 1 by t, or inverse of time. So velocity of wave is given by lambda into frequency. So this is the basic idea of a wave. So what are longitudinal waves? So we have said that non-mechanical waves, that is electromagnetic waves, they are transverse in nature. So what are the other electromagnetic waves? So you should have an idea that light is just one form of electromagnetic wave. What are other electromagnetic waves? So do you have an idea that what are the other electromagnetic waves? So you have this gamma ray, you have X-ray, and then you have your UV rays, then you have the visible. So this light is also electromagnetic wave. Then infrared is also electromagnetic wave. Then your microwave, then your radio waves, so they all are what? They all are electromagnetic wave. So if they all are electromagnetic wave, let me ask a simple question to you. So is the velocity of gamma ray, more than velocity of, let us say, radio waves? So gamma rays, you would have known that it is very dangerous. It is very dangerous for human health, plant health, environment health. Why? Because it can damage the DNA. So gamma rays are very damaging. Can you tell that whether the speed of gamma rays is more than the other electromagnetic waves? Is the speed of gamma ray more than, let us say, visible light or radio waves? Yes. Is the speed of gamma rays more than the other electromagnetic waves, or is it same? Because if you understand this, then many concepts will be clear. So speed of all electromagnetic waves is same. So we are saying that speed of all electromagnetic waves is same. So gamma ray speed is same as that of X-rays, same as that of UV rays, is same as that of visible, infrared, microwaves, radio waves. If the speed is same, then what is different? We are saying that speed is same for all electromagnetic wave. Then what is different? The difference lies in frequency. So gamma rays frequency is highest. So if you see, frequency of gamma is highest, and from this equation you can see that frequency and wavelength are inversely proportional. Inversely proportional means that if frequency is high, then wavelength will be less. So if frequency is high, wavelength will be less. So here we are saying gamma ray has high frequency. It means it has the lowest, one of the lowest wavelength, lowest lambda. And if we move down in this direction, the frequency is decreasing. So frequency is decreasing in this direction. So frequency of, let us say, your radio waves is low, but its wavelength is high. So visible light, so it has, you can say that it has frequency higher than, let us say, radio waves. So it has wavelength shorter than the radio waves. So do you know the importance of radio waves? Radio waves are being used for telecommunication. So your 1G, 2G, 3G, 4G, or even your 5G is what is radio waves only. We are not using light for telecommunication purposes. We are using radio waves only. We use light. We are nowadays you would be hearing about optical fiber. So optical fiber is being used for internet nowadays. We'll try to understand what is the principle in optical fiber. So this also will try to understand. There is a concept of total internal reflection. So we'll try to understand this. So before understanding this, we'll also try to understand what is this reflection and refraction. So this, let us first try to have clarity upon that. When we are saying electromagnetic waves, all electromagnetic waves, they have same speed. What is the speed? The speed is speed of sound, sorry, speed of light. So speed of light, what do you know? Speed of light is 3 into 10 to the power 8 meters per second in vacuum. Now when we say this, that speed of light is this much, 3 into 10 to the power 8 meters per second in vacuum, it means that the speed of light is dependent upon the medium. It might not need a medium, but if it is traveling through a medium, then the speed of light will change. So this is an important conclusion that you should know, that speed of light is not same in all the mediums. Speed of light changes in different medium. If you can understand this, then you can understand the concept of refraction also, that we'll see next. So are you able to understand this? That light is a electromagnetic wave, and it has frequency higher than visible light but less than your, let us say, gamma ray. Okay, we'll see even this application of visible light. Have you heard about Li-Fi? वाईफाई सुना होगा. Li-Fi क्या है? Li-Fi. Okay, we'll come to that. So now we have said that your light is an electromagnetic wave, light is a transverse wave. So transverse wave means that the particles are moving in this direction, in up and down direction, but the wave is moving in this direction. So that is why we call it as transverse wave. It is just like a battle rope or a gym rope. In gym rope also we are moving the hand in this direction, but the wave is moving in this direction. Similarly, light is also a transverse wave. It is a non-mechanical wave. So that are some of the features of the light. Now what do you understand by longitudinal wave? Longitudinal wave, what is longitudinal wave? Can you give example? Longitudinal wave example is sound, obviously, but it is difficult to visualize the wave of sound. So how can you imagine a longitudinal wave, or where do you in other places you see longitudinal wave? Can you give any example, a daily life example from your observation that you have seen with respect to longitudinal waves? Sound is a good example, but since you cannot see sound, so it is difficult to imagine that how it is a longitudinal wave. Okay, can you give an example of a longitudinal wave that you can see, that you see sometimes? Yes, anybody? Longitudinal wave. Okay, let me just give an example. Nowadays you would have seen that people place books in many books in a row. They will put many books in a row side by side, and when they push one book, the books start falling and they form a wave. So this wave is what? This wave is longitudinal wave. Why it is longitudinal? Because the direction of movement of the wave is same as the direction of the movement of the particle here. In your school also, when you are standing in a file in one line, if you push the boy or the girl in front of you, what will happen? The whole line falls. So it produces a longitudinal wave. So sound is also longitudinal wave. So it produces what is known as compression and rarefactions. So it produces regions of, let us say, these are your compression regions and these are your rarefactions. So sound is also longitudinal wave. So can you visualize longitudinal wave? And sound is which type of wave? Sound is a mechanical wave. It means sound needs medium. It needs medium. It can travel through air, it can travel through water, it can travel through liquids, it can travel through metal, but it will need a medium. It cannot travel in vacuum. That is the basic difference between light and sound. That sound is a longitudinal wave. It needs medium. It is a mechanical wave. Light, on the other hand, is transverse wave and it is a non-mechanical wave. That is, it does not need a medium. So light from sun, it is coming through vacuum only, and then it is entering Earth's air or environment, and then it is reaching us. So that is the basic difference between light and sound. So sound is also a wave, so it also has that same property, that it has a velocity, so it has wavelength and it has frequency. But frequency of sound wave in general, you can say that its frequency is less than compared to your light. Okay, so you would have known that the speed of sound is quite less than compared to speed of light. Now coming back to light here, now let us try to understand some of the concepts such as reflection. Reflection is a simple concept that you have an idea about. The critical concept here you should know is refraction, because this concept is asked time and again in your civil services, also in state services exam, also in your other competitive exams. So what do you mean by refraction? What do you mean by refraction? So refraction comes from the idea that light travels at different speeds in different medium. It travels at different speed at different medium. So let us say if this side is water and this side is air. So if light is entering water, then it should have traveled in this path only. It should have traveled in this path. But what happens is that it is bent towards the normal. So when it moves from a lighter medium to a denser medium, it bends towards the normal. So instead of moving in this direction, it now moves in this direction. So it is, this line is known as normal. This line is known as normal. And what you are seeing, when light is moving from lighter medium to a denser medium, light is bending towards the normal. So what is happening? See, in this case, it is said that when light enters water, speed of light decreases. Speed of light decreases. So we are saying that speed of light in water reduces by about 25%. So speed of light is, let us say, you say that it is some constant, that is 3 into 10 to the power 8 in air. But when it is entering water, we are saying speed is reducing by 25%. And speed, we have said that it is nothing but wavelength into frequency. Speed is wavelength into frequency. Now if c is decreasing, can you tell which among the two factors here is decreasing? Is the wavelength decreasing or is the frequency decreasing? When light is entering water, what is changing? Is the wavelength changing or is the frequency changing? Yes, anybody? So we are saying that when light is entering water from air, its speed will reduce. Its speed will reduce. Its speed will reduce by 25%. What is reducing? Whether wavelength is reducing or whether frequency is reducing? No idea? Just take a guess. There are only two factors. So frequency does not change. Frequency in any medium of light will not change. It is the wavelength which changes. So the wavelength is decreasing. So wavelength is decreasing, that is why speed of light is decreasing in optically denser medium. So light is getting slower and slower. So have you heard about refractive index? So refractive index, see, sometimes the terms are not very important, but you should have an idea. So examples are good way to remember. So if you have to remember refractive index, you just remember one thing: refractive index of diamond is highest. Refractive index of diamond is highest. So when I am saying refractive index of diamond is highest, what does it mean? That when light enters from air into diamond, then light is slowing to such an extent that it appears that light is crawling inside diamond. So what is this refractive index? Refractive index is speed of sound in air by speed of light in air by speed of light in the medium. So speed of light in the medium. So in the medium, in diamond, so in diamond, what is happening in diamond? So this value is this is basically a ratio. So this ratio, what is happening here, that this speed of light in diamond is very, very slow, and that is why it is coming to this value. So refractive index of diamond is highest. So what is refractive index? Refractive index, you can remember that it is speed of sound in air, that is C, divided by speed of, not speed of sound, sorry for wrong usage of the term. So it is speed of light in air by speed of light in the medium. That is what is refractive index. So are you able to understand this concept? So if you understand this concept, refractive index, so in the NCERT there are many examples given that we can see that when we talk about twinkling of stars, so this is about a prism. We'll see twinkling of stars. Okay, let me get back to slides itself. See, why stars appear to twinkle? So let us say let me just change the color. So let us say if this is a star, and this is our Earth, and what is happening, that this is our atmosphere. Our atmosphere is not a monolithic unit. It means in the atmosphere it is made up of different layers of air, and different layers of air have different density. So in a way, what is happening, that we have many layers of the air. So what is happening, when light is moving, when light is entering into Earth's atmosphere, so in different medium light is getting refracted differently. and because of that, so it is getting refracted differently. So because of that, the stars, they appear to twinkle. So it is not that the stars, the source of light is changing. What is changing is our appearance of that light. So it is different layers of air that is causing a refraction, and that is why it is causing the twinkling of stars. So there are other examples of refractions that you can see. So why do sun appears to be large during sunrise or during the sunset? So it is because of the refraction only. Common example of refraction is if you put a coin in a beaker. If you put a coin in a beaker and if you fill it with water, then you will see that the coin appears to be raised. The coin appears to be raised. Why? Again, because of the bending of light in different medium. So because of the bending of light, we are seeing these phenomena. So in refraction only, one of the important application of this concept of refraction is used in optical fibers. Is used in optical fibers. Optical fibers, nowadays we are using optical fibers for internet. आपके घर में ये टाटा स्काई या जियो का या फिर हाथवे का इंटरनेट जो लगा है, सो दे से दैट इट इज़ अ फाइबर नेट. It is a fiber net. So here we are using light as a medium to transfer data. So what is the principle inside these optical fiber? So the principle is refraction only, but a specific type of refraction. Here it involves the concept of total internal reflection. Total internal reflection. So let us try to understand this total internal reflection. So here refraction is only happening, but it occurs in such a way that it appears that it is a reflection. So in order to understand total internal reflection, let us look at this specific example. So let us say this is water and this is air, and light is moving from inside water to air. So in which direction will it bend? The normal course should have been this, but because it is moving from a denser medium to a lighter medium, it will bend away from the normal. So it is not going to bend this side, but it is going to bend this side. Is it clear? So we are saying that the light is going to bend in this direction. Light is going to bend in this direction. Now take another case. Let us take this case. Now the light is moving at this angle. Now light is moving at this angle. So the normal course should have been this only, but because it is moving from a denser medium to a lighter medium, what is happening? The light will bend towards or away from the normal, and here it will appear that it is moving along the surface. So what is happening? That this angle is how much? This angle is 90 degree. So this is angle of reflection, this is angle of refraction, this is the angle of incidence, and this is the angle of refraction. So here you are seeing that the angle is now 90 degrees. So any ray now that you take, so if let us say I am taking a ray, so this angle is now called as the critical angle. This is called as critical angle. This is called as critical angle. So why it is called as critical angle? So light, when it is moving at this angle, then this refraction angle is 90 degrees. So the light is appearing to move along the surface of water only. So if I take a source of light which is less than the critical angle here, then the light, instead of moving in along this line, it will start to appear that it is getting reflected in this direction. So can you see here that we have sent light, and beyond this critical angle, this ray of light is not moving out in the air, rather it is moving back inside the medium. So this phenomena, so now we are saying that internal reflection has began. Internal reflection has began. So this is the phenomena of internal reflection. So in optical fibers, how do we construct these optical fibers? So these optical fibers have some unique design. So you would have seen this. So it has a core, and then it has an outer covering. Again it so what is happening? This is optically denser medium. Let us say this is 1.7 and this is optically lighter medium. So imagine that this is air and this is water. So this is more dense. This is optically more dense. So what is happening here? That when light is moving beyond this critical angle, the light is not moving outside of the medium, rather it is coming back. It is getting reflected back into the medium. So here can you see that refraction is appearing, that there is not a refraction, rather there is a reflection. So you can imagine that beyond this critical angle, this surface, this boundary is acting like a mirror. So यहाँ से आप जो भी लाइट भेज रहे हो वो मिरर इसको मीडियम के अंदर रिफ्लेक्ट कर दे रहा है. यस खुशी, गुड इवनिंग. Good evening. So what is happening here, that this surface is now acting as a mirror and it is reflecting back the light into the medium. So in optical fiber, what are we doing? So let us say there is a light. I'll just change the color. So there is light is being moved in this direction. So it is moving from a denser medium to a lighter medium. So this surface is acting like what? A mirror. This surface is acting like a mirror, and the light is reflected back. So this light which reaches this point, it is reflected back. So it will reach, let us say, here. Again same phenomena is happening. So this is denser medium and this is lighter medium. So here also it is acting like a mirror. So light is again reflected here. So what is happening? So light is moving inside this fiber or a wire like structure, and it is not moving out of the wire, it is remaining inside the wire. So we are using the concept of what? Total internal reflection in optical fibers. So even if the wire is bent, it doesn't matter. Why? Because light will also move in that manner only. So this is the idea behind the optical fibers. So in optical fiber we are using this concept of total internal reflection only. Total internal reflection. Can you give any other example of like this total internal reflection where do we see total internal reflection? So if you take this is like water body, or water is here and there is air. If there is a bubble, there is a bubble of air, there is bubble of air. So what is happening? This bubble appears what? Shiny. Why this bubble appears shiny? Why this bubble appears shiny? Okay, so here also we are seeing the concept of internal reflection. See, the concept of internal reflection you will also see in case of what? In case of rainbow. So in a rainbow, what is the optical phenomena that is occurring? So that phenomena is known as dispersion. So light also has this quality of dispersion. What do you mean by dispersion? What is the idea behind dispersion? So you would have done experiments in school regarding dispersion. So dispersion is what? Dispersion is breaking up of white light into different colors. So when you take a prism and when you throw a light, so it divides into different spectrum. This you would have seen that it divides into different spectrum. So what is happening? You get a spectrum which is referred as Vibgyor. Okay, so in this dispersion, what is the idea? The idea here is that if you look it from the reverse side, white light is nothing but a combination of basic colors, combination of red, green and violet light. So white light it is not one light, rather it is a combination of different lights. So in this diagram you can see that the violet light has been deflected the most. Violet light has been deflected the most and the red light has been deflected the least. And this phenomena also we utilize in some places. So red light deflects less. Why? Because it has higher wavelength. It has lower frequency. But if even in white light you will see that this violet light has lower wavelength and higher frequency, so it is deflected more. So red light, why it is used in traffic lights? So why red light is used in traffic lights? It is because it has higher wavelength. It gets deflected less, so that is why it can travel farther. That is why red lights are used. So is this clear? So this concept of dispersion is also being utilized in what? It is also being utilized in your when rainbows are being formed. So when rainbows are being formed, these water droplets act as a prism, and the and what is happening? The sun is on this side, and this is the water droplet, and there are further water droplets that forms the screen. So these other water droplets, they form a screen. So what is happening? Light from the sun, water acts as a prism, and it gets broken down into different segments. So that is the idea of dispersion. Good evening, Satyam. Good evening. Good evening. Okay, so coming back to one of the property of light, that light is in 1 year UPSC had asked a question that why light is being used as as a unit to measure astronomical distances. See in your NCERT, light in the chapter light in your 10th standard NCERT, there are many problems that are given. So when it is passing through, let us say, mirror, when it is passing through lenses, then what is the formula, and where is the focus, where is the curvature, all those concepts. So that is not required for civil services. So you do not have to mug the formulas there or the numericals there. You have to develop a basic understanding of light. So you have to know that light, what is light? So light is a wave. Which type of wave? Transverse wave. It is a non-mechanical wave. You have to know the properties of light. That is all that is required from civil services point of view. So light, so in space science and technology, you will see that concept of light is being used. So they will ask questions like, why is light being used as a unit to measure astronomical distances? Astronomical distances, let us say the distance between sun and earth, it is measured in what? It is measured in something referred as light years. Light years. What do you understand by light years? What do you understand by light years? Good evening, Satyam. Good evening, Sneha. Light is used as a unit to measure astronomical distances. What is light year? What is light year? So light year is the time taken by the light to travel in a year. It takes only about 8 minutes for the light from the sun to reach earth. So it is just taking 8 minutes to reach light, or light takes 8 minutes from the sun to reach earth. So light year means the time. It is the time, or it is not the time, rather it is the distance traveled by light in 1 year. लाइट की स्पीड क्या होती है? सो लाइट की स्पीड कितनी होती है? कैन एनीबडी टेल? सो स्पीड ऑफ लाइट इज 3 into 10⁸ meters per second. और किलोमीटर्स में आप देखोगे तो ये हो जाएगा 3 into 10⁵ kilometers per second. It means 3 lakh kilometers per second. Do you realize how fast the speed of light is? Okay, so we are saying that why light is being used as a unit to measure astronomical distances. So you should also take a note, this speed that we are saying, this 3 into 10⁸ meters per second, this we are saying that this is speed of light in vacuum. In vacuum, that is the speed. But speed of light is not same in all the medium. Speed of light is slower in water or in denser medium. Speed of light is the slowest inside diamond. सर लाइट की स्पीड साउंड से ज़्यादा होती है? Yes, of course. See, sound. What is the speed of sound in air? Speed of sound in air. So first of all, you should take a note that sound needs a medium. So we calculate the speed of sound in air. This is just 330 meters per second. और लाइट का स्पीड कितना है? 3 into 10⁸. So can you compare? Light is much faster than sound. Sound is very slow in comparison to light. Do you realize that it takes only 8 minutes for light to reach from sun to earth? And what is the distance between sun to earth? It is in millions kilometers, but it is taking only 8 minutes. So it is traveling 3 lakh kilometers in 1 second. Here you are seeing it is just one third of a kilometer. It is just one third of a kilometer in 1 second. Yet even this speed is very high. Even this speed is very high. इस speed पे जो चीज़ें चलती हैं, जो speed of sound in air, this is also called as 1 Mach. 1 Mach. आपने सुना होगा कि कुछ चीज़ों को हम बोलते हैं सुपरसोनिक. आपके जो फाइटर प्लेन्स है उसको हम बोलते हैं सुपरसोनिक. कुछ फाइटर प्लेन्स सुपरसोनिक होते हैं, कुछ फाइटर प्लेन्स सबसोनिक. कमर्शियल एरोप्लेन्स दे आर सबसोनिक, they are subsonic, but some of the missiles they are referred to as hypersonic. So when you hear these terms, these are benchmarked with respect to speed of sound. Speed of sound in air is referred to as 330 meters per second, and इसको हम 1 Mach भी बोलते हैं. तो subsonic, I'll just take another slide. So 1 Mach is your speed of sound in air. So 1 Mach is speed of sound in air. See, these terms you'll keep hearing in defense technology. Speed of sound in air, that is 330 meters per second. इसको हम बोलते हैं 1 Mach भी. Okay, so when you say that the fighter plane is supersonic, it means that supersonic, we have a criteria that anything between 1 Mach and 5 Mach is referred as supersonic. So more than speed of sound but less than 5 times the speed of sound. Subsonic, anything which is traveling at speeds less than speed of sound is referred as subsonic. So if the speed is less than 1 Mach, it is called as subsonic. If the speed is more than 5 times the speed of sound, if it is more than 5 times the speed of sound of 5 Mach, it is called as hypersonic. Do you know any example of subsonic? जो कमर्शियल एरोप्लेन्स हैं, जिसमें आप ट्रैवल करते हो, दे आर सबसोनिक. दे ट्रैवल एट speeds less than speed of sound. But do you realize that even commercial aeroplanes are much faster than your trains? They are much faster than your train, but they are slower than speed of sound. Speed of sound is quite high, yes, but in comparison to light it is much less. Supersonic, any example of supersonic? You know, fighter jets, fighter planes. जो fighter jets होते हैं वो supersonic होते हैं. जो missiles, BrahMos missile. Have you heard about BrahMos missile? BrahMos missile एक cruise missile है. Cruise missile. This cruise missile travels inside Earth's atmosphere. So BrahMos missile is a supersonic missile. Agni missile का नाम सुना है? Agni missile hypersonic होगा. जो बैलिस्टिक मिसाइल्स होते हैं, चाइना ने रिसेंटली टेस्ट किया है hypersonic missiles. So they are traveling at speeds more than 5 times the speed of sound. S-400, have you heard about S-400? Last year mains question was there in civil services, that what is S-400? Why is S-400 considered to be the best missile defense system in the world? Have you heard about S-400? S-400 किसका है? S-400 किसका है? S-400 is of Russia. So someday we'll discuss about missiles and missile defense technology. S-400 is a missile defense system of Russia which India has bought. So it has bought one unit, and that one unit is costing around $1 billion. So what is this missile defense system? We'll try to understand later, but this is just to give you an idea that this missile defense system has missiles which can run at hypersonic speeds, that is more than 5 times the speed of sound. Is it okay? So if you compare, now if I ask you a question, let us say, since you have asked with respect to speed of light and speed of sound. So we said that when light enters water, When light enters water, its speed reduces. So speed of sound reduces in water. What about speed of sound in water? Will it decrease or will it increase? What about speed of sound in water? Will it decrease or will it increase? With respect to light, we said that speed will reduce, but sound, will the speed of sound decrease or increase in water? Priyanka, it does not decrease, it increases. The speed of sound is increasing inside water. आपने ये ऑब्जर्व किया होगा मेटल्स में कि speed of sound is increasing. If you take a plate, or if you take a long rod, if you put your ear near the rod, and if somebody flicks the rod at the other end, it travels very quickly and it reaches your ears. So in a denser medium, sound tends to travel faster. So sound will travel faster in water, whereas light will get slower in water. Is it okay? Okay. Yes, Falguni, good evening. Have you heard about sonar or radar? सोनार क्या होता है? Where have you heard this term sonar? Sonar is both sonar and radar are used for detecting objects. जब एरोप्लेन फ्लाई होता है या फ्लाई करते हैं एरोप्लेन को, तो एयर ट्रैफिक कंट्रोलर होते हैं. एयर ट्रैफिक कंट्रोलर क्या करते हैं? रेडार्स के थ्रू डिटेक्ट करते हैं कि एरोप्लेन कहाँ फ्लाई कर रहा है. सो रेडार्स में क्या होता है? रेडियो वेव्स. वी आर यूजिंग रेडियो वेव्स टू डिटेक्ट ऑब्जेक्ट्स. Detect object. Here in sonar we use sound waves to detect objects, and this sonar we use in mainly in underwater. So sonar is used to sound wave, and through that we can detect the objects. So sonar is using the principle of sound only. Okay, now coming back to this question, that what do you understand by light years? Light year क्या होता है? And why light is being used as a unit to measure astronomical distances? Can you tell why? Yes, yeah, quite correct. Now coming to this question, light years. What do you understand by light years? So light year is the distance traveled by light in 1 year time. So that is known as light year. And light year is used as a unit to measure astronomical distances. Astronomical distances means distances between, let us say, stars, planets, different galaxies. So that we are referring as light years. Because the distances are very, very large, we need some unit which has a very, very high speed. So we use light as a unit to measure distances. Now see, if I ask you a simple question, on earth to measure distances, what is the unit that we are using? On earth to measure distances, what is the unit that we are using? We are using a unit called as meter. We are using meter, and we have got what? We have made a meter rod, and this meter rod length has been standardized. So this meter rod length is standardized. It means this meter rod length is not changing. So 1 meter anywhere on earth would mean the same. 1 meter rod, so 1 meter would mean the same on earth. What if I say that if this standard meter rod that you have, if it can increase in length, if it can decrease in length, can you use then this meter rod as a unit to measure distance on earth also? You have said that this is a fixed rod and this is a meter rod and we are standardizing this, but what if that standard rod can increase in length or can decrease in length? Let us say in summers it increases in length, in winters it decreases in length. Can we use that meter rod as a unit to measure astronomical distance, to measure distances on earth? Okay, so quite correct. So we cannot use it as a standard unit to measure things. So light also, we have said that speed of light is not same. Speed of light is not same in all the mediums. Speed of light is different in, let us say, water, in air, or in any other solvent, or in any other medium. So why for astronomical distances we are using light as a standard to measure distance? We are saying that light, the speed of light is not constant. Speed of light is changing in different mediums. So how or why are we still using it as a unit to measure astronomical distances? Are you able to understand the question? Okay, so there is some delay, or on YouTube live there is some 10-second lag. So let me just give you the answer that yes, the speed of light is different in different medium, but when we are talking about astronomical distances, let us say distances between planets and stars, or planets between two celestial distance between two celestial bodies, then the medium that we are assuming there is vacuum only. So there is one medium, that is vacuum, or there is no medium at all. So we are saying that light will be constant, or speed of light will be constant there. That is why we are using it as a unit to measure astronomical distances. Okay, find out as a homework, just a small homework, what is this parsec? What is parsec? Okay, what do you mean by rectilinear propagation of light? Rectilinear propagation of light. And one more question, that can gravity influence light? Can gravity influence light? That is, can light bend also? Can gravity influence light? Okay, so if there are any doubts, so I can take, so, or else we'll close the session. So from tomorrow I'll be beginning with biology. So in biology we'll be looking at cells. We'll try to build very basic understanding of the cells itself, and then we'll see further concepts. Sir, what time class starts? This NCERT class we are beginning at 7 o'clock. So we'll start again tomorrow at 7 o'clock, 7 to 8. Light is affected by speed. Yes, light is affected by gravity. Yes, so in regions around black holes, light is affected by gravity. Yes, true. Okay, any doubts? So if there are no doubts, I'll close the session.